All right, guys, so solutions. We're going to talk about solutions and how they work. You should have some familiarity with solutions already because you just kind of know what the definition of a solution is. But let's go ahead and give our official definitions out. So you need to know these definitions. And so we'll just read through them real quick, but I'm expecting you to know these. So the parts of a solution, you have the solution, which is the substance, which is a substance in which one thing is dissolved in another. You have the solvent, which is the part that is doing the dissolving. The solute is being dissolved. So, for example, if you put salt in water, the salt would be the solute, and the water would be the solvent. So, for example, salt water, this is the salt and this is the water. The solvent is dissolving the solute, which is the salt. It is being dissolved. The word solvation refers to the process of dissolving. So if something is in the middle of being dissolved, it's in the solvation process. And if it has already been dissolved, then we say that it is solvated. So just a couple of little definitions to make sure that you understand and know. So let's actually look at the dissolving process, the solvation process, and what goes on when that occurs. And so let's say that we have some salt, and salt is made up of two kinds of atoms. It's made up of chlorine atoms. So let me draw a few chlorine atoms here. We'll make those green. And it's got sodium atoms as well. We'll make those blue. We'll make them a little smaller because sodium ions would be smaller than chlorine ions. And actually there would be a chlorine here in the middle as well. And so there's like a single layer of a salt cube. We have alternating sodium and chlorine atoms in that layer. Now, the water molecule, if you remember, water is this bent molecule, and it is polar. It's got a partial negative charge on the oxygen, and right here between the hydrogens would be the net partial positive charge. Now, for the sake of making this easy to draw, I'm going to draw water like this. So remember that right here at the point is the oxygen, and at the two ends over here is the hydrogens. This is the positive end and the negative end of a water molecule. For the sake of ease, I'm going to draw it like that. So here's what happens. If you remember, the chlorine atoms are negative because they have obtained an electron from the sodium atoms, which are positive. And so since water has these positive and negative ends, the partial positive and partial negative ends, they can interact with the salt. And so what happens with the negative here, the negative of the chlorine atom, well, the positive end of the water would be attracted to the negative chlorine. And so water molecules can come over here, and the negative end, which is the opened end where the hydrogens are, could be attracted to that chlorine. And they're going to attach to it, and they're going to pull on it. And if they have enough force, enough energy to overcome the bonds that are holding the chlorine ion in the crystal lattice, then it's going to pull that chlorine off. And that's what makes things soluble or not soluble. If water is strong enough, then the substance will be soluble and it will break apart. Or you could look at it vice versa. If the substance is weak, water can overcome its forces. If water cannot overcome its forces, then it won't dissolve. It'll just sit there and it will hold itself together. And so the idea of what makes something soluble versus not soluble is this idea of this tug-of-war, if you will, between the strength of the water molecules pulling on the ions of the substance and the strength of the ions holding themselves together. Whichever one is stronger will determine the solubility, or if it is soluble or not soluble to some degree. And so let's say that this substance is soluble. The water molecules will pull off this chlorine atom. This chlorine atom right here will separate out, and it will become surrounded by water molecules. And it's always the positive end of the water that it surrounds. This is the positive end of the water that surrounds the negative ion. So the negative end of the water is out here. And that ion is now solvated. It has been dissolved, that individual ion. Now, likewise, the water molecules, the negative end of the water molecules, can come over here and attract to the positive ions of the sodium, and again they can pull off, and so we would get a sodium ion that would be surrounded by the oxygen end, which would be the negative end. The oxygen's on the negative end of the water molecule, and so that ion is solvated, and this process simply continues. Water molecules will come in, attach, sorry about that, back up. Water molecules will come in and attach, and then surround, and then leave. Well, they'll attach. Some will attach. They can't get all the way around, and then they leave. Then the rest of the water molecules will surround it. And so eventually, this salt crystal would turn into a whole bunch of just solvated ions. And they would be surrounded by water molecules. And obviously this would all would occur in 3 dimensions, not 2 dimensions as I'm drawing here. And so eventually this crystal that is bonded together with ionic bonds, this crystal lattice, would be separated into the individual ions of the substance. It's still there. We just can't see it. You know, here you've got this big bulking crystal, and we can see that because there's hundreds of millions of atoms combined together. We can see them. But here they're individual atoms, and that's why we cannot see things that are dissolved, because the individual atoms are too small to see. They're separate one from the other. And so that's the solvation process. The solvation process is really simple. Water molecules come in, attach, and then pull off and separate, and the crystal structure of the substance is broken down into the individual atoms that are then surrounded by water molecules. So again, each of these is surrounded by water molecules on all sides. And that is the solvation process.